All right, so welcome to the Python version of the k-means clustering for our image segmentation. Some weird things are happening in here, so we'll have to just see what's going on. So just a quick look at the code. Um, to do the color conversion, I'm going to try to use the pillow package, although I do run into some issues. Besides that, for the k-means, we need the sklearn package. So, you know, hopefully everybody knows how to uh, get those packages if they need them. If you're having trouble with that, let me know. Um, so here we just open up the image as usual. Uh, this is an RGB image, and then we do an LAB conversion. Um, there are some formulas out there that you could use to do this, but it's always good to have it built in. And so then, so basically lines 17 to 25 are just really getting this image into the computer, converting it to LAB space, and then making it into some kind of a numerical array. Okay, so on line 25, the array Y should be a three-dimensional array. You know, the first two dimensions are the length and width of your image. And then I believe we have pulled off, oh, we haven't yet. The first two numbers are the length and width, and the next three numbers are the L, the A, and the B values. Okay, so we're going to pull off the first two, and we're going to reshape this so that, if, for example, if I have a 10 by 12 image, and the numbers there are numbers A and B, Um, so what I can do is I can rewrite that as a matrix that's 120 by 2, right? And so that's kind of what we're doing. Well, that is what we're doing here, except the numbers are a little bit bigger. So that's why this matrix is number of rows times number of columns by 2. So we're just creating a very long, very tall matrix here with all the pixels or all the position values in here, right? All this is going to be equal to the number of pixels in the number of rows, and then we'll have two elements, the A and the B. Okay, and then we do k-means on those two-dimensional. So this is a two-dimensional plotting or a two-dimensional clustering. Um, this is kind of nice. It lets you go through and initialize any number of times you want. 10 times is a good number. Um, and then so this is instantiating a value, the k-means, and then you actually put the data into it in the next line where we do the fit. So that's kind of a weird thing with Python. Okay, and so just to make it clear where the data files are in relation to what we saw in MATLAB, I went ahead and wrote those out. So let's go ahead and see what happens here. Um, yeah, I'm not sure what's going to happen. Well, I do know what's going to happen, but we'll take a look together. So I'm just going to run pieces of it first. Well, I guess I do have I get separated into cells. Maybe I should do that. So maybe that's one cell. This will be the next. Oop. Oh, maybe we can't do the cells here. I thought that was a cell. Kind of similar to, oh, maybe it is similar to, there's the cell. Good. And then, yeah, so then you don't have to run everything at once. You can just run cells. Good. Let's see how that works. All right, so let's go back here and run this cell. Good. So everything looks good so far. You can see in the variable explorer that we've got all of our things here. Y is the three-dimensional array. This is the length and the width of the image, and the three values here are the L, the A, and the B values. So M is our original image. Temp is just you can see what we had to do here. we had to convert the image to an array, right? Um, so let's go to the next cell. Good, everything went. And so now Y2 is the 837,000 data points we're going to be using in R2. Okay, and so then we're going to be clustering that. That's going to happen in the next cell. Let's go ahead and run that. And then we should also get the image. Good. Now, this is kind of a strange thing. If you've watched the two MATLAB files, you know that this is not looking right. And I'm not sure why that happened. So what I did was I went ahead, let's go ahead and clear the memory out. So that's a Control L, and then we'll clear the variables, and then we'll go to the, let me clear that again. We'll go to a shortcut file. And in the shortcut file, the only thing I did was I put out the MATLAB's version of the LAB file, so I don't have to do any of the image processing in Python, just to see what happens in this file. So let's see what kind of clustering we get now if MATLAB does the LAB conversion. Beautiful. We get just what we expect. So there's something wrong. Well, I shouldn't say something wrong. Something's different about the LAB conversion in Python than in MATLAB. And I don't want that to be an issue because we could go down lots of rabbit holes looking for that problem or looking for that issue. If you're interested in colors and color processing, you might take a look at the LAB color space and see if you can find the difference. And tell me. Otherwise, I will have the image format there so that you can upload, so you don't have to do the image processing in Python yourself. Although I'll put both of these files up. One of them is image segment shortcut, and the other one is image segment example. So the shortcut file is the one that bypasses Python's own color conversion file. Okay, all right, so that's it. I will see you later.